We use Newton's method if we want to estimate the root of a function. And Newton's method itself is essentially an iterative method. When we say it's an iterative method, we mean we make a first guess or a first estimate, then we continuously improve on that estimate until we cannot improve it anymore, then we can stop. That is how we do the Newton's method. It is also called the Newton-Raphson method. You may find in other books they call it Taylor's method, but it is one thing. I'm just going to explain how you approach that. So in this video, I'm going to calculate the smallest positive root of 3x cubed minus 2x squared plus 6x minus 1. I'm going to do this using Newton's method. So let us go to it. I'm going to start here. So our f of x, which is our function, is 3x cubed minus 2x squared plus 6x minus 1. F prime of x, which is the first derivative of f of x, is 9x squared minus 4x plus 6. Now, Newton's method itself can be summarized in a formula. I'm not going to explain to you how you derive the formula. I'm just going to use the formula. So Newton's method can be summarized in a formula. Let us say we are looking for x1, which is an improved estimate. It will be x0 minus f of x0 over f prime of x0. This is the formula that you use. X0 will be our initial estimate or our first guess. It's x0. Then we're going to get x1 from it. If we have x1, we can find x2. And x2 will be x1 minus f of x1 divided by f prime, which is the first derivative, first prime of x1. This gives us a better estimate than x1. We continue doing this until we have two consecutive answers that are similar, correct to the number of decimal places that we want, correct to a certain accuracy that we were prescribed to achieve. Let us say if we say your answer should be 3 decimal places, it means if you have two consecutive answers that are the same to 3 decimal places, then you have to stop. This is how you do Newton's method. How many iterations you do depends on how good your first guess was. If your first guess was far away from the correct answer, you are going to do a lot of iterations. This is where experience comes in. This is where some methods that you have to use to make a better guess, that's where they come in, so that you don't have to do many iterations. Now, in essence or in general, xn is equals to xn minus 1 minus f of xn minus 1 divided by f prime of xn minus 1. This is the formula. This is Newton's method, or Newton's rule, as it is called. We continuously use this formula throughout. This is why I already found f of x and f prime of x, because we're going to need them in our formula. Now, I want now to explain how you get the first guess x0, because this is where it matters. If x0 is a very good guess, we're not going to do many iterations. If it is a bad guess, it means, or a bad estimate per se, it means we're going to do many iterations, which may not be a good thing. Now, let us wrap this and I show you how you make your first guess. So let us go to how we make our first guess. Okay, first estimate, x0. So first estimate, or we can call it a guess because it is indeed a guess. X0. How you find it? With the information that you have, one, you can sketch the curve. If you sketch the curve, it will show you at least that it is passing through two numbers. If you make a sketch of the curve, for example, let us say I sketch the curve and I get a curve like this. Because this is a cubic function, I get a curve like this. Then the smallest positive root, obviously it will be here. What we call a root of a function, it is the position where the function is cutting the x-axis. So if this root, this root is a negative root, I will not be interested in it. This will be the positive root that I'm looking for. If I sketch this graph and I find that here I have, maybe here I have 1 and here I have 2 and here I have 3, then I can know that my root is between 2 and 3. So my first estimate may be x0 equals to 2.5, which is the middle of 2 and 3. This is how you do. So you can sketch the curve and read your curve or read your sketch and see where the curve is crossing the x-axis. That's the root. And you find the two numbers between which it is crossing. Then you use them, use the middle of those two numbers as your first guess. So this is one way. It is quite, it takes time to do this. There is a quicker way. A quicker way is, so the second way, which is what I'm going to use in this example, you find the value of the function between two numbers. If there's a change of sign, it tells you that the function, the root is between those two numbers. Let us say we find f of 1. We find that f of 1, let's say it's 7. And then we find f of 2. We find that f of 2 is minus 4. Because this is positive and this is negative, this tells us that between 1 and 2, the graph crossed the x-axis. So there's a root between x equals to 1 and x equals to 2. This is what you can use. As long as there's a change of sign between the two numbers, then you can know that there is actually a root between those two numbers. The problem with this approach is that we can have a situation where the graph comes in and goes up between two numbers. Let's say we have a 1 here and a 2. You can have a graph coming in like this, and which means there's a root here and there's also a root here. But if you use this method, you're not going to detect that between 1 and 2 there is a root, because here the graph will be positive and here at 2 it will also be positive. That's the problem with this approach. However, in such cases, the question might usually guide you in giving you the first guess to use. You might be guided, but I'm going to use this method here in our case to estimate, or to rather make the first guess where this root lies. So let us go to that. Let us go back here. I'm coming back here. Now I want to find x0, our first guess. So let me remove all of this. I want to remove all of this. All right. Now, since we're looking for a smallest positive root, I'm going to assume that it is between 0 and 1. So let us find here f of 1. No, f of 0 first. F of 0. If I put 0 into this function for x, I'll get minus 1. So it's like 3, 0 cubed, minus 2, 0 squared, plus 6, 0, minus 1. I get minus 1. This is f of 0. Then I go on to find f of 1. F of 1. This is 3 by 1 cubed minus 2 by 1 squared plus 6 by 1 minus 1. From here I get 3 minus 2. So this is 3 minus 2 plus 6 minus 1. I get a 6 here. 3 minus 2 plus 6 minus 1. I get a 6. let us find f of 2. Just want to check something. So this is 3 by 2 cubed minus 2 by 1 squared plus 6 by 2. No, this is 2 squared. 6 by 2 minus 1. So we punch that. This is 2 by 2 cubed minus 2 by 2 squared plus 6 by 2 minus 1. We get 19. So here I get 19. What does this tell me? The root lies between 0 and 1, because here I got a negative answer. I got a negative, or the graph is negative, which means it is below the x-axis. And on f of 1, the graph is positive, which means it is above the x-axis. So there is a root between 0 and 1. This is a conclusion that we can make, that the smallest positive root of this function actually lies between 0 and 1. Very important. So now let's go to the calculation now. Now that we know that our root lies between 0 and 1, we can now make our first guess. It is advisable to always take the first guess as the middle of those two numbers, which in our case, it means x0 should be 0.5. 0.5 should be our first guess, or our first estimate, 0.5. Please remember that our f of x is 3x cubed minus 2x squared plus 6x minus 1. This is our f of x, and our f prime of x is 9x squared minus 4x plus 6. Now, armed with x0 and our Newton's method formula, we can now go on to find our first guess, our beta estimate, which is x1. So x1 will be x0, which is 0.5, minus a f of 0.5, which means in the f of x, where we have x, we are substituting 0.5, so which is 3, 0.5 cubed minus 2, 0.5 squared plus 6 times 0.5 minus 1, and we divide all this by 9 times 0.5 squared minus 4 times 0.5 plus 6. All we do from here is to punch in our calculator and get x1 a beta estimate. I get my answer as 0.2. So x1 is 0.2. So this is equal to 0.2. From here, I look for x2, which is a better estimate than x1. So it will be 0.2 minus 3 by 0.2 cubed minus 2 by 0.2 squared. So we square this plus 6 times 0.2, minus 1. All this over 9 times 0.2 squared minus 4 times 0.2 plus 6. Punch in our calculator, we get 0.3, which is a better estimate than 0.2. Punch in our calculator, we get x3, which is always a better estimate than x2, And so let us punch in our calculator and see what we get for x2. x2 is 0.174. That is our x2, 0.174. 0.174. So x2 is a better estimate than x1. We have to find another estimate again until we have two consecutive answers that are the same, correct to 2 decimal places. In our case, our standard is correct to 3 decimal places, because that's we require our answer to 3 decimal places. So if we have our answer correct to 3 decimal places, 2 consecutive ones being the same, then we stop there. So let us use 0.174 to find another better estimate. Let me clear here and start fresh. So now we know that x2 is 0.174. Let us look for x3. x3 will be 0.174 minus 3 times 0.174. You're not writing, so minus 3 times 0.174 cubed minus 2 times 0.174 squared minus plus 6 times 0.174 minus 1, this part here over 9 times 0.174 squared minus 4 times 0.174 plus a 6. If I punch this in my calculator, I get 0.174 again. So 0.174. Now I have to stop. x2 and x3 are both 0.174. They are the same, correct to 3 decimal places. I don't have to do the iteration anymore. If I continue using 0.174, I will also get a 0.174. So there is no need to keep doing it, because you won't be improving your answer anymore. It means the smallest root of our function is smallest positive root, is 0.174. Thank you for watching the video. If you have any comments, write in the comment section below. Subscribe to the channel, and don't forget to give a thumbs up to the video and share with your friends.